I'm Preston.
And I'm Nick.
And today we are going to explain a problem where we take related rates, implicit differentiation, and basic algebraic techniques to an applied situation where two lights between two buildings meet at a specific rate of change.
The problem is a straight street of width 20 meters is bound on its parallel sides by two vertical walls, one of height 13 meters and the other of height 8 meters. The intensity of light at point P at ground level on the street is proportional to the angle theta, where theta is equal to APB, at points shown on the diagram.
Action.
So part A is asking us to find an expression for theta in terms of x, where x is the distance from P from the base of the wall of 8 meters. So we have this diagram, and we have point P, which is right here. So we're going to label these two angles alpha and beta, and then we're going to make this length x, and then this other length 20 minus x. So we know that this whole angle has to equal 180, which is also equal to pi in radians. So pi is equal to theta plus alpha plus beta. And we know that the tangent of alpha is equal to 8 over x, and that the tangent of beta is equal to 13 over 20 minus x. So alpha is equal to the inverse tangent of 8 over x, and beta is equal to the inverse tangent of 13 over 20 minus x. So when we put all of these into the equation, we have that pi is equal to theta plus inverse tangent of 8 over x plus inverse tangent of 13 over 20 minus x. So when we solve for theta, we have theta is equal to pi minus inverse tangent of 8 over x minus inverse tangent of 13 over 20 minus x.
Okay. So part B is asking, calculate the value of theta when x equals 0. So what we do is we take the equation found in part A and then you plug in 0 for x. So the equation found in part A is section 1, theta equals pi minus the inverse tangent of 8 over x minus the inverse tangent of 13 over 20 minus x. So what we do now is just plug in the 0 for the x values. So theta equals pi minus tangent over 0 minus the inverse tangent of 13 over 20. Okay. And then we know from our pre-calculus class that the inverse, when is the ask yourself, when is the inverse tangent undefined, and that is at pi over 2. So you have theta equals pi minus pi over 2 minus the inverse tangent of 13 over 20. And now you just plug in this value into your calculator, and then you get that theta equals 0.994 in radians. Alright, now part 2 is asking to calculate the value of theta when x equals 20. So just like in part 1, we just substitute x for 20. So theta equals pi minus inverse tangent of 8 over 20 minus the inverse tangent of 13 over 0, because 20 minus 20 is 0. Okay, so theta equals pi minus, you just plug this into your calculator later on, but let's figure out, we know that the inverse tangent is undefined at pi over 2 here. So you write it like this. And then you plug it into your calculator, and then your final answer is 1.19 radians. Okay, so part C is asking, sketch the graph of theta for when x is in between 0 and 20. So we'll just draw our little axes right here. So there's 20, the y-axis, and then there's the x-axis, and then here's 0, and then here's 20. Okay, and then from part B, we found out that when x equals 0, y is or theta is equal to 0.994. So that's like 1 is right here, so 994 is right here. Okay? And label this 0, 0.994. And then also from part B, we found out that when x equals 20, theta equals 1.19. So that's right here. 21.19. Okay. So to find out how the graph is drawn, we plug into our calculator. And our equation was y equals pi minus the inverse tangent of 8 over x minus the inverse tangent of 13 over 20 minus x. And this is the graph. 20, yeah. So you just draw it like this. And voila, we have our graph.
So we just found the derivatives of these inverse trigonometric functions. So now we're going to put them back into our equation. So we're going to have d theta dx is equal to negative 8 over x squared plus 64 minus 13 over 569 minus 40x plus x squared. So once we distribute the negatives, we're gonna have d theta dx is equal to 8 over x squared plus 64 minus 13 over 569 minus 40x plus x squared. So in order to combine these, we're going to have to find a common denominator. So we're going to rewrite this as 8 times 569 minus 40x plus x squared minus 13 times x squared plus 64 all over x squared plus 64 times 569 minus 40x plus x squared. So now we're going to expand everything. So this is going to be equal to this quantity after we combine a bunch of like terms. And from the numerator, we're going to factor out greatest common factor, which is 5. And it is going to end up as 5 times 744 minus 64x minus x squared over x squared plus 64 times 569 minus 40x plus x squared. That's what we had to prove up here.